Good afternoon.
Good afternoon,
Hi.
Professor.
Okay, so last class we start talk about recursion, and we know on recursion, it's when we have a function that calling its own task. So you will see on a function calling from Excel, right? And then there are some rule and advice I give you when we're working on recursion. First is when you call on its own task, it can only call the easier version of the task, so you cannot make it harder. Right? And you also need to code for the easiest case, right? Which pretty much in HQL, there's a stopping point. Once you reach there, you won't keep looking for the easier task. And there is some advice I give you. So don't ask how C++ does the recursion, right? So you will just trust the rule above here, right? So you will just follow the rule and trust that it will does its job. So instead of asking how C++ work, you should ask yourself, what's the easier version of the task that will help you to do most of the work? Okay, and when you trying to code the recursion, or when you're trying to code your function, you should begin your code by detecting and solving the base case. So you will have your base case first, right? So the base case, that will be your easiest task. So let's look at the first example. So it's similar to what we did last class, the last example we did, right? So the last example we did in previous classes, we print like a triangle. So from 1 star to 4 star. Now we want to print an upside down triangle. So we have the function called the D triangle for the upside down triangle. So the D triangle 4, it will print you the 4x4 triangle, but upside down. So how do we do this?
You create a function called dTriangle that returns no. It was a nested for loop inside that draws the upside down triangle. You just pass in 4 as a parameter.
Okay, again, we are working on the recursion. So yeah, so we could do this function without the recursion. You can do it with nested for loop like what we did before. Now the point here, we're trying to write it as recursion.
It could be like last time where you draw the stars for that row and then call the recursion thing, but just the order would be different from last time of when you do the recursion and when you draw the dots.
So if you look at it, right, this triangle here is the triangle 4. Now, when we call for the easier version, what should we look for?
The last 3 lines.
So the last 3 lines. And what is this?
D triangle 3.
So this will be the triangle 3, but we also need, right, the first row. First row, which is 4 stars, and then plus the D triangle, and this combined together give you D triangle 4. Now for D triangle 3, it will call on the triangle 2, triangle 1, and then triangle 0. Now when we look for the triangle 0, we will expect it to print nothing. Right, so if we come back to it, right, so we know this is a function, where you don't need it to return anything. Right here, you don't need to return anything. So we have a function of void type, and then this function name is the D triangle, and then we need to pass in the size of the triangle you want to print. So let's call it int n. Now, if you look at it, to print this triangle n, we need to print the first row. Now, first row will give you n star. So we will have a for loop here to print a row of n star. So going from going from 1 up to n, C++. And then we will see out a star. And then after that, after the for loop, we need to end the line. And then, so this here, it will give us the first row, which give us n stars. And then we need to call the easier version. Which will be the D triangle -1. Now, what do we forgot here?
I think you just return, right? Not return 0.
Yes, we just need to return here since it's the void type. Now, what else are we forgot here?
The base case.
The base case. Right, so if you look at it, if you look at the advice here, we should begin our code by detecting and solving the base case. And we know base case is when we reach 0, we will print nothing. You will just return there. So we have if n equal to 0, we will just return. You don't need to do anything. So we can stop there. Any questions here? And so if you look at the difference between this code and the code we have last time, let me just copy and paste here. The difference between this code and the triangle function we got last time is where we call the easier version and then the last line. Right, so for the regular triangle, you will print the easier version, and then you will print its last line. Where for the D triangle, you will print the first line, and then you will have the easier version, where you will have the triangle 3, triangle 2, and then triangle 1. So let's print both. So let's print this is triangle 4. And then we will print out the D triangle 4. I forgot a semicolon here. Let me show you the code. So this is our code. We'll run it. Right, so for the triangle 4, right, we will print the easier version. So you will print the triangle 3. Triangle 3 will call for the triangle 2, triangle 1, triangle 0. It prints nothing, and then it will print you the last row for the triangle 1, and then last row for the triangle 2, last row for the triangle 3, and last row for the triangle 4. And then it will return. We will get this triangle. For the D triangle 4, it will print you the first row for the upside down triangle 4, and then we'll call for the D triangle 3, and then we'll print the first row, and then call for the D triangle 2, and then we'll print you the first row, and then call for the D triangle 1, and then we'll print the first row of the D triangle 1, and then call for the D triangle 0, and then we'll just return, and then you will keep hitting the return until you reach the top. Right, see, so the order in which you put down the code matters. Right, so the C++ will run the code as the order you put in the code. Any questions here? Okay, if not, we will move on. Now let's look at the next example. Let's say we want to write the number digit function, which this function called num digits, which it will give you number of digits. So for example, if we see out num digit 3, 1, 4, 1, 5, it will print you 5 since this number have 5 digits. Now let's say your number is always a positive. Your number is always a positive integer. Okay, so here we assume the input is positive integer. So how do we do it? So if you look at the number digit, what's the easier version? So we know to do recursion, we need to ask yourself, what's the easier version? Or what's the easier task?
Trying to figure it out for 4 digits, taking off one of the digits.
Okay, so let me give you some choices. So which one will be the easier version? So I see people say just have the one that with 4-digit left. Now, if you look at it, both have the 4-digit left. You take off one of the digit. So if you look at the first one, I take off the first digit, where the second one, I take off the last digit. Which one is easier to do?
The second one,
The second one.
because you could just divide by 10.
Or we can get this number by 31415 over 10, right? Because over 10, it will chop off the last digit. But if you want to take off the first digit, it will be much harder because you don't know how many digits you have.
Wait, how do you
Questions?
know it's divided by 10? I'm a little bit confused. We got that.
Okay, if we divide it by 10, what do we get? Again, this is integer division, right? Our input is an integer. And then we have integer divided by an integer. Again, we are looking at the integer division, right? So if we have integer divided by an integer, our result will be an integer,
Oh, okay.
right?
Yeah.
Remember, it will ignore the decimal part.
Yeah.
So if you divide it by 10, right? Normally, it's like our decimal place will move 1 to the left, but since we ignore the decimal places, it pretty much chop off the last digit,
Okay. Thank you.
right? So when we're working on question involving the digit, especially with the integer, dividing 10 and modulo 10 usually help you a lot. So divided by 10 always means it will get rid of the last digit, and modded by 10 give you the last digit. So it depends on, do you want to get rid of it or do you want to get the last digit? Now, if you want to get last few digit or get rid of the last few digit, then you will just raise 10 to whichever power. So if you want to get rid of the last 2 digit, you can do divided by 100. If you want to get the last 2 digit, you can mod it by 100, right? So here we will do 10. So the easier version will be a number divided by 10. So if you look at the number digit of n will equals to what? So we know we will look at the easier version. So it will equals to the number digits of n over 10, then what? If you look at this will give you 4
Plus 1.
plus 1, right? Since we divided by 10. So this is the easier version. Now, now besides that, right, if you look at our rule number 2 before, we need to also call for the easiest case. So what's the base case?
0 digits.
How do we have 0 digit?
If we have like 1 digit and you divide by 10.
Okay, I see people say when n over 10 equal to 0. So if n over 10 equal to 0, what must your n be?
Single digit.
a single digit. So your base case will be what? When you have a single digit, right? So it will be when n is less than 10. When n is less than 10, this means single digit. Now, when n is single digit, what do you need to return?
1.
So you will return a 1.
But can we do it like the last one where we get to 0 and then we return 0?
Yes, then what do you let n be?
As long as
Then you can say when n equals to what?
equal to 0,
Then what do you return?
return 0.
So that's also fine. So if you do n equals to 0, return 0, it's fine. So you will either do it like this, or you will do it as the single digit. And the reason you allow us to do that is because we're assuming our input is a positive integer. So when your input is 0, we just treat it as like 0 digit because we don't consider 0. Okay, now to write our code. So we know the number digit, it will return as an integer, right? So we know this function will be int, and then followed by the function name, so number digits. And then our input will also be an integer. So let's call it integer n. Then we need to store our code with the base case. So if n is less than 10, we will just return 1. Or you do it as if n equals to 0, then we return 0. And then we know the number digit will just equal to number digit n over 10 plus 1. So we just return. We will look at the easier version, the number digit of n over 10, and then we will add 1 to it. So this will be our answer. So besides the base case will return 1, everything else you will just look at the easier version. Number digit of n over 10, which you chop off one of the digit, then you will add 1 to it. So if you look at here, we will expect the answer to be 5. Or if we just change it a little bit, we say C out. Let's say enter a positive number. We need to declare a variable n, and we will store it in n, and then we will just see out the number of digits of your input. So let's save it. So here's our code. And let's run it. So if our input is 31415, it will return as 5. If we run it again, just input number 5, it will tell us 1. If we run it again, we input number 1, 2, 3. And let's say have some 0 digit at the end. It will also give us 6. Any questions here? Okay, I see people say, why are we adding the 1? If we divide it by 10, it will chop off the last digit. So when you look at the easier version, it will give you the number of digits for the first, for the first 4 digits. Right, so so what it does is you start with you start with 3, 1, 4, 1, 5, right? So when you pass in, right, when you do the number digit, it will chop off the last digit. So it will call for the 3, 1, 4, 1. But 3, 1, 4, 1 will only return to you 4. So you need to add 1 to it because you getting, since you divided by 10, so you get rid of 1 digit. So this adding the 1 is the last digit you get rid of. So if you look at it here, so when you ask for the how many digits does 3141 have, it will call for the easier version. So it will ask how many digits does 314 have, and then it will ask how many digits does 31 have, and how many digits does 3 have. 3 is less than 10, so it will tell you you have 1 digit for 3, and then you need to add 1 to find how many digits for 31, which is 2, and then you need to add 1 to find how many digits do you have for 314, which is 3, and you need to add 1 to find how many digits that 3141 have, which is 4, and you need to add 1 to get, you have 5 digits for 31415. Do we see that? So I kind of told you how does the C++ work, but you should just trust that it will give you the easier version. So it will give you how many digits do you have for n over 10. But you know, if you compare n over 10 with number of digits for n, they are 1 digit apart. So you need to add 1 to n over 10 to get number of the digit for n. Okay, now let's find let's write a first digit function. Again, we assume our input is positive integer. Which if you print out the first digit for 314, it will print you 3. So if you look at it, what's the easier version of the first digit here? What's the easier version of first digit of 314?
31.
You can look at the first digits of 31. Now, what do we expect the outcome of the first digit of 31?
It's the same as for 314.
It's the same for 314, so we still return a 3. Now, what's the easier version? Can we still go down? Like, what's the easier version for the first digit of 31?
3.
So we can look for the first digit of 3, and then we will expect it to be 1. Now, can we keep going down? No. Right, so we should stop here. So when should we stop? When n is what?
Less than 10.
When n is less than 10. Now, when n is less than 10, what should we do?
Return n.
Return n. Right, so we should just return the value. So this will be our base case, right? This is the simplest version. So once you reach there, you don't want to keep going down. So to write the code, right, we know the first digit function, it will return an integer. So we have int first digit of int n. Now we will start our code with the base case. So we know if n is less than 10, we will return n. Else, what do we return?
First digit of n divided by 10.
Right, so for the digit 314, we look at 31. For 31, we look at 3. So besides the base case, we will just look at the easier version. It will be the same answer. So we will look at the first digit of n over 10. It will be the same. Any questions here? So here, if we just see out the first digit of 314, 15, just do a few more digits, well, we will expect the answer to be 3. So let's save it. So here's our code, and we will expect it to print out a 3, right? So it will print you the first digit. Can you scroll up to example 2? This one? Okay, I see people say in the function we can have return 0. Okay, so if you want to return 0, then you will say if n is equal to 0, then we return 0. Right, remember we say like here, right, the base case you can have 2 versions. Either if your n is less than 10, which means you have single digit, then you will return 1. If your n equal to 0, then we will say it's equal to 0, right? Since we assume our input is positive integer. But I will say it's probably better to do it with one n less than 10 because technically if you enter 0, you should still return 1 since 0 is 1 digit. But since our input is positive integer, so if you say when n equal to 0, we return 0, it's technically still. So that's why we will select the first one. Okay. Now let's say I want to find the biggest digit. So I call this function big digit n, which will return the biggest digit or the largest digit. I see people asking, so the +1 is not associated with the simpler function. No, the +1 in the earlier question, the +1 is when you're trying to find number of digit for n. The easier version is you can look at 3141. But if you compare number digit for 31415 with 3141, the easier version will give you 1 digit less since you are getting rid of the last digit. So this will only give you 4. So to solve for the actual answer, you need to add 1 for the digit you get rid of. So if you look at it, your number digit will equal to the easier version +1, +1 for the number for the last digit you get rid of. So it's not like you can think of it as the counter, but I should say, I will say the +1 is like how we define the function. Okay, I see people still asking why do we do n over 10? Why do we do n less than 10? When we have the number to be less than 10, that means we'll have single digit. So when you have single digit, we don't divide, we just return 1. Because once you have single digit, you don't want to divide it anymore. You just say you have 1 digit. You only have 1 digit left. So that will be the base case. Okay. Can we move on?
Yeah.
And now if you look at here, so I want to find the biggest digit. So for example, if I have the big digit of 31415, you will expect it to return to you 5, since 5 is the largest digit. If you do the big digits of, let's say, 1, okay, so let's say you have 1925, then you will return 9. So let's look at this two scenario here. I give you two cases. What's the easier version for the big digit of 1925?
192.
Okay, then you will look at the big digit of 192, which we would expect it to print out 9, which is the same answer. Now what's the easier version for the big digit of 192?
19.
You will have the big digit of 19, which will still give you 9. Now, if you look at the easier version of the big digit for 19, what's the easier version now?
1.
1. Now, if you look at what's the biggest digit for 1, what does it return to you?
1.
Now, can we still look for the easier version for big digit of 1?
No.
No, right? Since you only have 1 digit left. So we should stop when n is less than 10. Now, when n is less than 10, what should we return?
N.
We'll return n. So this again is our base case.
Like the one to return the wrong value.
Yes, because if the question asks you what's the biggest digit of 1, then the answer will be 1, since there's nothing you compare to. You only have 1 digit. So that will be the biggest digit. And now, what's your answer here returned? Now, if you look at it right here, this answer here, right, the big digit of 1925 is the same as the big digit for 192, since the last digit you chop off is 5. And then the same thing here, right? The biggest digit for 19 is 9, since your biggest digit here is greater than 2. But once if you look at the easier version for 19, the biggest digit become 1, since you get rid of the last digit, which is 9. Same thing if you look at this example here. The easier version will be 3141, and that will return to you 4. But we should return a 5. So when you write this function, right, we know we will return an integer for the big digit, and then we would take an integer n as input, and we will begin our code with the base case. So when n is less than 10, we will just return n, since there's only single digit, have nothing to compare to. So we take care of the base case. And now, how do we find the big digit of n?
I guess you compare the smaller function to the last digit and see which one is bigger.
Yeah, so we need to compare the easier version and the last digit. Right, so for your big digit of n, you will need to compare. Pretty much you will take the maximum of the easier version of n minus 1 and the last digit. and we get the last digit by n. Here, n over 10, we get the easier version. And then the last digit, we get that by n mod 10. So we need to compare the two, right? We want to take whichever it's max. So we will compare it. So we will say if, or you know what, let's calculate what's the easier version. So let's let x equals to the easier version, the big digit of n over 10, right? We'll chop off the last digit. Now, if x is greater than the last digit, we will return x. Else, we would return n mod 10. Do we see that? This is example 4. So again, if n is less than 10, we will return its value. Otherwise, we want to compute what's the easier version. Now, the reason I uncreate another variable so I don't compute it again. Right, so n over 10, that will give you the easier version. And then we will compare whichever is larger. So if x is greater than the last digit, n mod 10, we will return x. Else, you can just return here, since if it passed the if statement, it will return, it will just end there. So it won't keep going. So it doesn't matter you have the else here or not. So else we will return the last digit. So here we will see out the big digit of n, 31415. Let's do one more. Of 1925. Okay, so we will expect the answer to be 5 and then the 9. Save it here. So here's our code. So we will get the first one, right? The largest digit is 5, and then the second one, the largest digit is it's 9. Any questions here? Now you can also make like a small change to find the smallest digit. So what change do we make so we can find the smallest digit?
Make the greater than into a less than.
So if we change this greater sign to the less than sign, then you will be able to find what's the smallest digit in your number. Okay, so we will end the class here. In next class, we will practice more recursion.
Thank you, Professor.
Okay, have a nice weekend.